Okay, so today we're going to be working on some proofs for both algebra and geometry. So we're going to start out with just some properties that we will be using in our proofs. So the first one is the reflexive property. So what that tells us is that for every number A equals A. We know that. For every number 3 always equals 3. Okay, we can also say that AB equals AB if we're talking about segments. And we can say that the measure of angle 1 would equal the measure of angle 1 when we're talking about angles. Okay? So then the next one we have is the symmetric property. So for all numbers A and B, if A equals B, then B equals A. We use this one oftentimes when we're trying to prove something, but we have them in the reverse order. So let's say we're trying to prove that B equals A, but when we work it out, we get A equals B down at the bottom. So then we use this symmetric property to be able to flip their positions. Same thing for segments. AB equals CD. So then we can say CD equals AB. We just flip the positions of them. And for angles, the measure of angle 1 equals the measure of angle 2. So then we could say the measure of angle 2 equals the measure of angle 1. Again, just flipping those positions from one side to the other of the equal sign. Okay? The next one that we have is the transitive property. The transitive says for all numbers A, B, and C, so now we're working with three things. If we know that A equals B and B equals C, then we can say that A equals C. So if you notice here, we took the beginning. We have the same thing here at the end as we start with here, and then the ending. So we just cut out the middle and said that A equals C. Okay, and we can do the same thing for a segment. ABE equals CD, and CD equals EF. We're cutting out this middle piece that's the same for both, and we're leaving the rest of it. We're just smushing it together to get AB equals EF, which is what we have here. Same thing for angles. The measure of angle 1 equals the measure of angle 2. The measure of angle 2 equals the measure of angle 3. Then we're going to cut out this middle part that is the measure of angle 2 and smush those together so we get the measure of angle 1 equals the measure of angle 3. Okay? The next one we have is addition and subtraction. You've been working with these for quite a long time, I think. So for all numbers A, B, and C, if A equals B, then if we add C to both sides, so A plus C and B plus C, or if we subtract them from both sides, those are our addition and subtraction properties. So we use this when we are working with equations. So let's say x plus 2 and 3 plus 2. So we added 2 to both sides. Then that would be our addition property if we're subtracting the same thing from both sides. Because you remember, whatever we do to one side, we have to do to the other in order to keep it balanced. So that's where we use these. Same thing for multiplication and division. Oh, I forgot my n there. That's multiplication and division. For all numbers A, B, and C, if A equals B, then A times C equals B times C. So as long as we multiply by the same thing on both sides, then we're fine. And over here, as long as C is not 0, and we divide by the same thing on both sides, then we keep our equation balanced as well. Okay? Couple more. We also have substitution. Substitution is a really common and important one. So for all numbers A and B, if A equals B, then A may be replaced by B in the equation or the expression. So whenever you find x equals 3, then you can put 3 in everywhere that you see x in your equation or expression. And this is the property that allows us to do that. And then the last one is distributive, and I believe most of us have been working with this one for a while as well. For all of our numbers A, B, and C, when we have something like this where we have B plus C in parentheses and A is multiplied by that parentheses, then we just distribute A times B plus the A times the C, and that would be the distributive property. Alright, so then we're going to go on to some examples. So what an actual proof looks like. So this is the first one that we're going to be looking at. So when you get your statements, you'll see them in two different ways. The first way is an if-then statement. So if we know this, then this must be true. Okay? So when we do a proof, we always start out with our given. So that's our if piece. So we have 3 parentheses x minus 5 divided by 3 end our parentheses equals 1. And that was our given. And then the next thing we're going to do, anytime we have parentheses with something outside multiplied here, we're going to distribute. So that's our reason there. We're going to be distributing. So 3 times x minus 3 times the 5 over 3 equals 1. And then the next thing we need to do is we need to simplify. So if we look through here, this piece, the 3 times the 5 divided by 3, can be simplified. And if you remember back at our properties, anytime we're trying to simplify something by plugging something else in, that is called our substitution property. Okay, so we're going to substitute. We're going to substitute 5 in for this expression, because if we actually work that out, these 3's will cross each other out and become 1. 1 times 5 would be 5. So 3x minus 5 equals 1. And again, we took this piece and we substituted 5 in for it. Okay? Alright, so then the next part, if I was solving this equation here, the next thing that I would do is I would add 5 to both sides, so that's what I'm going to do. 3x minus 5 plus 5 equals 1 plus 5. So I did the same thing to both sides. I kept it balanced, and what did I do? I added. So this is the addition property. And then the next thing I'm going to do is substitution again, because I'm going to simplify this piece. So 3x minus 5 plus 5 is 0, so I'm not going to do anything there, equals 1 plus 5 is 6, and that was substitution. I kind of think of substitution just as our simplification step. If you need to simplify something or reduce it to lowest terms, that would all be under substitution. So then the next step here, if I'm solving, I'm going to want to divide by 3 on both sides. So this is 3x divided by 3 equals 6 divided by 3. So that's our division property. Okay. And then to simplify, again, simplification, we also call that substitution. We're substituting a simpler form in. So here we're left with x equals, on the right hand side, 2. Okay? And that is what they asked for up here. They have x equals 2 written exactly like what we found. So we are finished. Great, let's try another one. So this is another algebra proof. These are the simpler of them. We're going to do an angle one as well as a segment one. Those are a little bit more abstract, so I want to make sure that we talk about these first so you can kind of see how everything works. Alright, so again, we always start with our given. This one is written differently than the last one. The last one was an if-then statement. This is a given and a prove. So we start with our given, and then we're going to be finding whatever it said for prove. So writing our given. So we have 7 divided by 2 minus n equals 4 minus 1/2 n. That was our given. Okay, so then the first thing that we're going to be doing here is I don't like these fractions, so I want to get rid of those. And how do I get rid of those? They divided by 2, so I'm going to multiply by 2. So I'm going to multiply both sides by 2. 2 times my 4 minus 1/2 n. So that was multiplication. So then if you remember, the next step, whenever we have these parentheses, is we're going to use the distributive. That's our distributive property. So we're going to take 2 times the 7 divided by 2, and we end up with 7 equals 2 times the negative n, or excuse me here, that's not an equals, that's a minus 2n. Now we can put our equals. 2 times the 4 is 8, minus 2 times the 1/2 is 1, so we just put n. Then the next thing we're going to do here when we're solving is we need to get our numbers on the same side and our coefficients with the variables all on the same side. So if we look up here, we can see that the n is on the left. So I'm actually going to move my n to the left. So I'm going to be adding n. So this is 7 minus 2n plus n equals 8 minus n plus n. So I'm adding n to both sides, so that's addition. So now if you remember, in order to combine some of these and simplify it, we're going to use substitution. So over here we have 7, negative 2n plus n, we still have a minus n, equals, we have 8, negative n plus n, we're left with no n's, so we don't need to put anything down here. Alright, so I'm going to slide this up a little bit. Still trying to solve for n, so I need to get rid of this 7. So I'm going to have 7 minus n, and I'm going to subtract 7, because this was a positive 7, equals 8 minus 7. So that's the subtraction. Subtraction there. So then to simplify, that would be substitution. So 7 minus 7 would be nothing. We're left with a negative n equals 8 minus 7, which is 1. Now I still need n. I have a negative n. So in order to deal with that negative, I'm going to actually use my division property again. I'm going to divide by a negative 1. So this is a negative n divided by a negative 1 equals 1 divided by a negative 1. So that's division. You could also have multiplied by a negative 1, and that would have been the multiplication property. I chose to divide, so that's why I put the division property. So a negative divided by a negative is a positive, so I'm left with n equals a 1 divided by a negative 1 is a negative 1. So this is substitution. So now I have n equals a negative 1, and that is what I wanted from up here at the top. N equals a negative 1. So I have proved what they asked me to prove, and I am done. Okay. Let's go on to one with angles. I have one here dealing with angles. So we're going to take a look at that right quick. So we're looking at an angle 10 and an angle 2. So our given tells us the measure of angle 2 is congruent to 60, and angle 2 is congruent to angle 10. So we're going to prove that the measure of angle 10 equals 60. Alright, so in order to do that, the first thing we're going to do is put our given. So the measure of angle 2 is congruent to 60, and angle 2 is congruent to angle 10. Now you will notice sometimes you'll see the congruent symbol with two lines, like an equal sign and then the squiggle above it. Sometimes you'll see it with one line and the squiggle above it. They both mean the exact same thing, it's just two different ways of writing it. Again, this was our given. So then the next thing that I'm going to be doing here is I'm trying to prove that that angle 10 is 60, and I know that if angle 2 is congruent to angle 10, then the measure of angle 2 equals the measure of angle 10. And that's just the definition of congruent angles. So that's one of those definitions we had a while ago of congruent angles. Okay, so you'll have to use your definitions as well. It's not just those properties I gave you, but it's definitions, postulates, theorems, anything we've talked about you could use as a reason in these proofs. So then the next thing is that 60 equals the measure of angle 10. And how do I know that? Well, I took this and substituted it in here. 60 equals the measure of angle 2, so I substituted it in there. So this is substitution. So that's what I did there, is I took what I already knew from the given and I plugged it in here. So now that's here, and this still comes down here, so that's why we call that substitution. Now up here, it has these in a flip-flop position, and if you remember, we had a property that helped us with that to flip them, and that was the symmetric property. And that just means we're going to flip those positions over our equals sign. Now we have it exactly the way that they want it, and we are done. Okay, I have one more here I want to do. This one deals with segments, just so you can have an idea of all of the possible ones that are out there. So this one, again, it's written as a given and a proof. So we're going to take that given, and that's what we're going to do first. So we have PQ equals RS, and that's our given. So they're saying P to Q equals R to S. So I'm actually going to put that little hash mark in there to say that those are equal to each other. And let's see, so the next thing that we need to do is we're trying to prove from P all the way over here to R is equal from Q all the way over here to S. So we have these little pieces, but we need to add this center piece in. We don't have that yet, so that's the next thing I'm going to do. So I'm going to add my PQ to the center, which is QS, or QR, excuse me. So PQ plus QR. And what does that equal? Well, that equals our two endpoints, which are P and R. And then this bottom piece here, I'm going to take my QR plus RS equals the whole thing from end to end, which is QS. And we know that these two statements are correct because that is our addition property. So that is our segment addition property. Okay? And that's these two. Okay? So then, in order to get my given to look like these, I'm going to take PQ plus QR equals, remember, whenever we add something to one side, we have to add it to the other. So this is going to be QR plus our RS. So this is our addition property. because we added QR to both sides. Okay, so then the last thing we're going to do is we're going to take what we have here and we're going to substitute it in for these. We're going to simplify them. Okay, so substitution. If we know that PQ plus QR equals PR, we are actually going to take this and plug it into here. So now we have PR equals, we're going to take QR plus RS equals QS. So that's going to get plugged in there. So that's QS. Using our substitution property, we took this that we knew and we're plugging this in that is equal to it. Same thing here. PR equals QS. That's what they asked us to prove at the top. So we are done. Alright, that's it for today. I'll see you in class tomorrow.